try to solve another Leetcode problem 934, shortest bridge. So we are given a n times n binary matrix grid, so where 1 represents land and 0 represents water. So an island is a four directionally connected group of ones, not connected to any other ones. So let's just check the first example. Let me try to use another color, maybe white. So we are having this kind of a grid, and 0 represents the water, and 1 represents the land. So this is 1, this is the land, and this is water. So what we're gonna do, we're gonna return the smallest number of zeros we must flip to connect the two islands. So 1 is just the islands, we want to connect them, but there is a 0. So this means we're gonna flip this 0 to 1, or this is 0 to 1. So it means at least we're gonna need one flip. So we're gonna return 1 because we want to return the smallest number of flip from 0 to 1. Yeah, so this is just a very simple example. But what if the island or the grid can be really complicated? So for example, we have two components. We have two land. So this is one land, this is one. Another is land 1. And in between, definitely it's going to be 0. But we don't know how many zeros. We're going to check the shortest distance from the above island to the below island. Yeah, so we want to check this kind of distance. So the idea is that we're going to use the DFS. So for example, if we find a 1, and we're going to use the DFS to find all the ones inside of the island. Definitely there's a lot of ones. Yeah. And after we find this one, we want to put it inside a queue or inside a priority queue, because we want to check the distance from this island. So there can be many ones, many positions, but we want to check the shortest distance from the above island to the bottom island. So maybe here, yeah, maybe here can produce the shortest distance. And what we're gonna do after that, we're gonna use the BFS to search until we find another one. Yeah, because after using this the above island, after we are checking the DFS of this island, we find a 1, we're gonna turn it to 2. So after that, all the numbers of ones gonna become 2 for the above island. Yeah, but for the bottom island, it's gonna still be 1. And what we're gonna do, we just want to use a BFS to search, and at the same time, we're gonna use the priority queue with BFS. If we find a value for the island which is 1, this means we've already found it, and we're gonna return the distance. But what if it is still 0? So we're gonna put the distance inside of the queue. Yeah. So for example, currently at all these positions inside the above island, the distance is gonna be 0. Yeah. So the distance is gonna be 0. But after that, if it go out, maybe here, so we're gonna increase the distance by 1. The distance is gonna become 1, and here the distance is gonna become 2. But what about here? And from here, the distance is 3, but we find the value inside this island, it is 1. So it means we find the shortest distance. So we're going to return the shortest distance, which is going to be 3. Yeah, so there are going to be 2 steps. First step going to be the DFS is used to put all the possible positions inside a priority queue. And then for the BFS, we're going to use this priority queue to find the shortest distance. Yeah, now let's just try to use this kind of idea to solve the problem. So we're going to prepare R and C as the length of the grid and the length of the grid 0. And then we're going to prepare directions. So it's going to be 4 directions, 0, 1, 1, 0, 0 minus 1, and minus 1 and 0. Yeah, so this is going to be the 4 directions. And then we're going to prepare a function of DFS. It's going to be R and C. And currently, let me give a pass. Yeah. Now let's just start for the main function. So we're going to check all the values inside the grid. Yeah, so for seeing range with capital C, and we want to check the value for this grid. If the grid R and C are equal to the value, which is 1. So this means definitely this is an island, and I want to connect all the islands. So I'm going to use the DFS to check all the islands. I mean the value going to be, which the value going to be 1. So I'm going to run DFS for this from this position. But I want to put all the possible positions inside of priority queue. So I'm going to prepare an empty priority queue. And after running the DFS, definitely I'm going to put all the possible points inside of this priority queue. Now let's just start the DFS. So we're going to prepare this grid R and C. All the values we're going to turn from 1 to 2. So this means at this position has already been visited. Now let's just check the 4 directions and update the 4 directions. So it's going to be R plus DR and C plus DC, and we're going to check the if it is inside the boundary for the row and column. Yeah, so currently it is inside the boundary, and we have to check the value for this grid row and column. Yeah. So if the value is still 1, it means it is an island, and we're gonna run the DFS for this row and column. After that, we're gonna turn this grid row and column to 2. Yeah, so this means for the first island, we're gonna turn all the values here from 1 to 2, and then we're gonna start DFS to find it. Yeah, find the second island, because there are gonna be 2 islands exactly, and I think it is sad, and there are gonna be 2 islands. You may change 1 to 0. Yeah, because there are 2 islands. Connect the 2 islands to form 1 island. Yeah, because there are only 2 islands. Yeah. Now, after running this DFS, we collect all the points to this priority queue. But where should we put it? So from here, we can put it. So we can use heap push with this priority queue and a tuple. The first value gonna be the distance, because we're gonna use a priority queue. So the first position gonna be the first value gonna be distance, and then R and C gonna be the position. Yeah. Now we can from here we can check this BFS. So while something inside of the priority queue, so we're gonna pop out the distance, position. So for the position, let me use maybe let me just use X and Y, maybe. Yeah. So for distance and the position X, Y gonna be gonna be the heap pop from this priority queue. And now we pop out the distance and pop out the positions. Yeah. So from this position we're gonna search. So how many positions we can search? There are 4 directions. So we're gonna use the 4 directions to search. Yeah. Let me just copy the code. I think here gonna be the same. Yeah. So in 4 directions, I'm gonna update this row and column. So it's gonna be updated to maybe here. I'm gonna use this dx and dy, and here gonna be x plus dx and y plus dy. Yeah. So this gonna be the 4 directions. Now I want to check if it is inside the boundary or not. Yeah. It's gonna be the same. Let me just copy here. So if it is inside the boundary, and then I want to check this value for this row and column. I mean for the new row and new column, I want to check the value. If it is 1, it means it must be another island. So I can return the distance immediately. Yeah, because from here it is inside the boundary, and then I want to check the value. So if it is 1, it means I find another island, and I can return the distance immediately. But what if the value is 0? So it means I didn't find it, and I want to search. So I want to update the value. So for this grid row and column, I want to update this value to 2. This means it has already been visited. Yeah. So for the next time, if I didn't put a value to 2 or 3, I will have an infinite loop because it is still 0. Yeah, I will visit this cell several times. So if I set it to 2, it means for the next time I will not visit it. Yeah, so that means here I can set a value to 2 or 3, it doesn't matter. And now we want to put the row and column inside of the priority queue. So we're going to use the heap push. So inside it's going to be pq, and it's going to be a tuple with distance of d plus 1 and row and column. Yeah, so this is going to be the entire code for the problem. Yeah, first of all, we're going to use a DFS to find all the possible positions, and we put it inside of the priority queue. And secondly, we're going to run this DFS to find the shortest distance, because BFS is used to find the shortest distance, and from here, this is just BFS. Let me just submit it to SAP. As you can see, it works. Now let me just submit it. As you can see, it passed all testing cases, and the time complexity is just m times n and n times n. Yeah, maybe you think there are 2 for loops, and here is a DFS, and here is another priority queue, but actually it is not like that. Yeah, because while we are finding these areas, we are just checking these areas. Actually, this is m times n in these areas. Now, from here, we just run the BFS. So from here, we are just checking the new areas, because these areas have already been checked. We didn't check anymore. This is just the new areas. We are searching for the new areas. Yeah. And now, if we find it, so we're gonna return a final value. So the time complexity is gonna still be m times n. We didn't increase any of the time. I mean, there's just one loop. We checked these areas, and then we checked these areas and find the result. We didn't repeat it many times. So this is why the time complexity is gonna be just m times n. Yeah, or maybe here, and there is a priority queue. We put some values inside the priority queue, maybe m times n times log m times n. Yeah, but basically I think m times n is okay for this problem. Yeah. Yeah, even here we used the priority queue. Yeah, we used the priority queue for those values. And yeah, so I think the time complexity for this algorithm should be m times n times log mn. So this is going to be the final time complexity. So it's going to be n squared log n, because the length, yeah, the column and row, it is both n. So it's going to be n squared log n, because here is a priority queue. Yeah, I think that's all for it. Thank you for watching. See you next time.